You are listening to The Vocal Technologist. Spoken tech for your ears.
If you think AI coding tools are making devs faster, I've got awkward data.
Yeah, you and me both, mate. It's a bit of a mess right now.
It really is. Welcome to Vocal Technologist. Grab a seat. We are going to untangle what is actually happening in the trenches of web development right now. Because, there is this massive grinding friction between the marketing hype we all see and the really messy reality of writing code.
Oh, massive friction. It is two completely different worlds.
Right, and we've got a huge stack of data to walk through to suss this out. We've got developer surveys, we've got internal benchmark audits from Anthropic, and some, frankly, wild usage stats coming out of Cursor.
Yeah, it's a bit of a collision course because we are seeing incredible adoption of these tools across the board.
Yeah.
Like if you walk into any engineering department, everyone has an AI assistant docked in their editor.
Everyone. It's just standard now.
Exactly. But the actual output, the actual shipping of features, is telling a very different story.
Which is exactly why I want to pick it apart. We are going to look at why generating more code definitely does not mean faster shipping. We're going to look at why the newer, massive AI models are sometimes demonstrably worse than the old ones.
Yeah, that part is wild.
It is. And we'll also look at how old-school foundational engineering is making a massive comeback.
The data on this is just fascinating, but you really have to look past the top-line numbers. Because if we look at the telemetry coming out of platforms like Cursor,
Yep, the AI code editor.
right, the editor, the disparity in how people actually use these AI tools is wild. You have the top 1% of power users, right? They are generating up to 40,000 lines of code per week.
Wait, hang on.
Yeah.
40,000 lines in a single week.
Up to 40,000, yeah.
That is absurd. I have to ask, is that even a good thing?
Oh.
Because if I am managing a team, right, and some bloke drops 40,000 lines of code on my desk on a Friday afternoon, I am not giving him a high five. I'm panicking.
And you should be panicking. Because when you look at the median user, they are only generating about 700 lines in that same time frame.
Okay, that sounds way more normal.
It is. So you have this massive, massive skew. But here is the critical detail, the thing that changes how we understand all of this.
Okay.
90% of the AI token usage during coding is input tokens.
Input tokens.
Yes.
Meaning the AI is reading code, not writing it.
Exactly. That is the actual reality of the workflow. Developers are spending the vast majority of their time feeding their existing code base into the prompt.
Just to give it context.
Right. They're trying to understand legacy functions, or they're trying to give the AI enough background so it doesn't just, completely hallucinate a non-existent library.
Yeah, which it loves to do.
It really does.
Yeah.
So devs are reading and wrangling context. They aren't just blazing forward, writing pristine new features.
So it's like speeding up a factory conveyor belt to 100 miles an hour, but the quality control inspector at the end of the line is just one bloke with a clipboard.
That is exactly it.
You are not actually increasing production. You are just creating a massive pileup at the exit door.
That factory analogy is a perfect illustration of the theory of constraints. Have you come across that?
Broadly, yeah, but explain it for us.
So in any complex system, improving a non-bottleneck step is just an illusion of progress.
Right.
AI has massively increased the raw generation of text. It basically solved the typing bottleneck. But that just shifted the constraint further down the pipe. And now the real bottleneck is code review.
Right, because someone still has to read all that generated text.
Exactly.
If you are a senior engineer listening to this, you are probably feeling this in your bones right now. Your juniors are submitting massive features, but you are the ones stuck reviewing it.
Oh, companies are absolutely drowning in pull requests. A junior developer might finish their feature incredibly fast using a generative tool.
Because they just hit tab and it auto-filled 50 lines.
Right. But then that code sits in a review queue. Senior engineers are overwhelmed trying to verify that this massive influx of AI-generated architecture is actually safe, secure, and functional.
It's just a mountain of homework.
It is. So the dev team is producing way more volume, but the business is not actually shipping software any faster.
And it is causing actual literal fatigue. I was reading this post-mortem from a developer who generated 900,000 lines of AI code for a new product.
Oh, wow.
900,000. And his ultimate conclusion after all of that was that human architectural oversight is completely non-negotiable.
Yeah, mate.
You cannot just let the AI drive the architecture. He was talking about severe LLM burnout.
LLM burnout is becoming a very, very real phenomenon, and it's a different kind of tired than regular coding fatigue.
How so?
It comes from the sheer monotony of fixing repetitive AI slop.
Slop, yeah.
These tools make false assumptions, they introduce these weird stylistic quirks, and cleaning that up requires a very specific, incredibly draining type of cognitive load.
It really is like editing a highly confident, incredibly fast junior developer who absolutely refuses to learn from their mistakes.
Yes.
Like, you fix a weird variable naming convention on Tuesday, and on Wednesday they do it again 1,000 times.
Every single time.
And the worst part is the AI slop often starts with the code base itself. Like, if your existing code is a bit dodgy, the AI just looks at that, assumes it's the house style, and matches that bad pattern perfectly, right?
Well, 100%. It just holds up a mirror to your technical debt and then multiplies it. And this connects to a broader conflict happening right now in the industry.
Yeah.
Some people call it the software engineering war between builders and keepers.
Okay, builders and keeper.
Yeah, so builders prioritize sheer speed. They want to wire things together, deploy features, get immediate user feedback, and move on.
Just ship it.
Just ship it. Keepers, on the other hand, are focused on system integrity, meticulous architecture, and long-term stability.
Right, and AI is basically a super weapon for the builders.
It absolutely arms the builders. But it creates a monumental headache for the keepers, because the keepers are now tasked with maintaining these sprawling, complex systems built on rapidly generated, often very fragile foundations.
I am looking at this data and getting frustrated, though.
Why is that?
Because if I am paying for the absolute newest frontier models, I expect the code to be pristine. We constantly hear about these multi-billion-dollar models dropping from OpenAI or Anthropic. Surely the tech companies know about this slop and they are fixing it with the newer versions.
You would assume so, right?
Nope.
But the telemetry actually suggests the exact opposite.
Really?
Yeah, we're seeing a very clear trend where supposedly upgraded models are actually regressing in key technical areas.
Regressing?
Yeah, going backwards. For instance, testing with Claude Sonnet 5 showed that for certain developer tasks, it can actually incur higher costs and produce inferior output compared to the older Sonnet 4.6.
Wait, hold on. You are telling me we have these massive, incredibly expensive tools that are meant to be the absolute cutting edge, and the upgrade is actually making things worse?
Yes.
How does a supposedly smarter AI get worse at coding?
It mostly comes down to how these models are trained for human interaction. Take tool calling, for example.
Okay.
Models like Opus 4.8 and Sonnet 5 are showing a massive regression where they produce malformed tool calls. When they interact with strict data schemas, like a JSON file, they frequently append extraneous fields or conversational text that just completely breaks the integration.
So they are hallucinating extra data.
Well, it is not a hallucination in the traditional sense. It's actually a side effect of their training.
Okay.
These frontier models undergo intensive reinforcement learning to be polite, chatty and helpful.
Right, to act like a friendly assistant.
Exactly. So a developer asks for a strict data output, and the model's politeness training basically overrides its deterministic logic. It spits out the code, but adds a little conversational preamble like, sure, I can help you with that schema. Here's your data.
Oh, no. And that friendly little greeting instantly breaks the API because the receiving server expects pure data, not a chatty robot.
Yep. It just crashes.
That is wild. By the way, if you're keen on us picking apart this sort of chaos, make sure you're subscribed. Because, mate, this gets even weirder when you look at actual business outcomes.
It really does.
I saw the assessments on Fable 5 and Opus 4.8. They scored an absolute 0 in improving website conversion rates. 0.
Yeah, that is the ultimate reality check for the industry right now.
Yeah.
We rely heavily on artifact metrics.
They're what, exactly?
Meaning how long a model performs in an isolated, theoretical test environment.
Right.
But artifact metrics do not always translate to real-world business value. When a massive, expensive model fails to move the needle on a basic metric, like a conversion rate, it forces companies to reconsider their entire strategy.
Right, you can't justify the cost.
Exactly. Major players like Eli Lilly are already abandoning these massive frontier models for certain tasks, and they're favoring smaller, purpose-built models instead.
But what about the benchmarks? Every time a new model drops, my feed is just flooded with charts showing it scored 90-something% on some advanced coding test. Are those tests just having a lend?
Honestly.
Yeah.
A lot of them are deeply flawed, yes.
Are they?
Yeah. Anthropic actually did an internal audit of SWE Bench Pro, which is one of the most widely used and respected coding evaluation benchmarks in the industry.
Okay, the gold standard, basically.
Right. And they found that roughly 30% of the tasks in that benchmark are fundamentally broken.
30%.
30%.
That is a massive margin of error for an industry standard test. If a university exam had a 30% error rate, there would be riots. How are they broken?
Mostly, they feature overly strict tests that fail perfectly valid code, or the prompts are entirely underspecified.
What does that mean in practice?
It's like failing a driving test not because you crashed the car, but because you didn't adjust the rearview mirror in the exact undocumented sequence the examiner secretly wanted in their head.
That is infuriating.
It is. You have models failing, not because they cannot code the solution, but because the test itself is rigged or poorly designed. Anthropic actually had to retract a recommendation to use that benchmark.
So just to recap, the giant models are stumbling, their politeness training is breaking basic schemas, they are failing to improve actual business outcomes, and the tests we use to prove they are smart are a third rigged.
That sums it up, yeah.
It makes complete sense why the smart money is pivoting them.
The pivot is very real, and it is moving rapidly towards systems that are small, cheap, and highly deterministic. The industry is finally waking up to the illusion of token pricing.
The illusion of token pricing?
Yes, comparing AI models purely by looking at the price per 1 million tokens is a totally meaningless metric.
Because different models tokenize text differently, right? Like I read that one model might use 3 tokens to read a complicated word, while another might only use 1.
That is a big part of it, yes. The tokenization varies wildly, so the only metric that actually matters for a business is the cost per completed task. And when you look at it through that lens, using a massive general-purpose probabilistic AI model for routine, predictable tasks is a phenomenal waste of money.
Let's break that down for a second, because we throw around words like probabilistic and deterministic a lot.
It is a crucial distinction. Large language models are probabilistic.
Right.
Underneath the hood, they are essentially highly advanced guessing engines. They look at the text and calculate the statistical probability of what the next word should be.
Which is why they are so good at creative writing, but also why they occasionally hallucinate or break strict formats.
Exactly. And a deterministic system is the complete opposite. It follows strict hard-coded rules. If A happens, do B, every single time, without fail.
It is like firing up a liquid-cooled supercomputer just to do your pub trivia math, when a basic $5 calculator would give you the exact same answer without the massive electricity bill. We do not need a probabilistic model to guess the answer to 2 plus 2.
Exactly. We need deterministic AI. App-level deterministic processes should handle the basic, predictable workflows. Not everything needs to be sent to a frontier model. Not everything needs to cost a token.
I saw a brilliant example of this from Kappa.ai.
Oh, yeah, the RG stuff.
Yeah, so they were struggling with retrieval augmented generation, or RG. And for anyone not elbow deep in this stuff, RG is basically giving AI an open book test. You feed a bunch of your company's private documents into the AI so it can answer questions based on your specific data rather than just the general internet.
Right, it grounds the model.
But stuffing that context window with documents gets incredibly expensive.
Very expensive. Because every single word you feed into that prompt costs money. The larger the context, the higher the cost per query, and the slower the response time.
So to fix this, they trained a really small, cheap language model to act as a bouncer.
A bouncer, I like that.
Yeah, its only job was to look at the retrieved context chunks and throw away the useless ones before passing the remaining highly relevant data to the big, expensive model.
That's smart.
It is. They managed to throw away 68% of the context right at the door, slash their costs dramatically, and still kept a 96% recall rate.
That is just brilliant systems engineering. It is using a cheap, targeted AI to optimize the expensive AI. And we are seeing these smaller models achieve incredible traction in really specific verticals.
Like what?
Well, look at GLM 5.2. It is nearly perfectly accurate at doing UK SME quarterly VAT returns.
VAT returns.
Yeah, it is matching the accuracy of a human bookkeeper, but operating at less than 1% of the cost.
Less than 1%.
Less than 1%.
That is the sort of stat that keeps accounting firms up at night.
Oh, it is triggering very serious warnings of a massive AI margin collapse. If small, cheap models can handle daily, specialized tasks that effectively the economics of training and running the massive generalist frontier models, starts to look very fragile.
Because why pay top dollar for a massive generalist model that might give you a chatty, broken JSON file when you can run a cheap, locally hosted specialist model that gets the exact right result every time?
Exactly. But there is a more urgent reason companies are scrambling for these smaller models.
Oh.
It is not just about saving money on tokens. They are literally hitting physical limits.
Ah, the hardware crunch.
Yes. We treat the cloud like it is magic, just floating out there.
Yeah.
But it is just massive buildings full of servers, and those servers require a phenomenal amount of power and cooling. AI labs are projected to spend over $100 billion a year just to acquire high-quality training data and power these data centers.
100 billion.
A year.
The physical bottleneck is just fascinating to me because we are so used to software scaling infinitely. You just spin up another instance. But I was reading about the Stargate project down in Texas.
The Microsoft and OpenAI one.
Yeah, it is this massive multi-billion-dollar AI infrastructure build-out, and it is stalling, not because they cannot generate enough electricity, but because they are stuck in the grid interconnection queue.
It is a bureaucratic and physical traffic jam. The electric grid has this outdated first-come, first-served queuing system for connecting new industrial facilities. So you can have all the venture capital funding and compute hardware in the world, but if the physical grid cannot safely plug you in without browning out the local suburbs, you are stuck waiting.
So compute is incredibly precious.
Mm.
Power is precious. And that brings us full circle to the actual code being written by these developers.
It really does.
Because if compute is the bottleneck, if power is the constraint, you cannot afford to have bloated, inefficient software running the foundation of your apps.
No, you can't.
Which is why we are seeing a massive renaissance in raw, old-school software engineering.
The pendulum is definitely swinging back. For the last couple of years, the focus has been entirely on AI-generated speed. But developers are recognizing that they need to rewrite core infrastructure tools in faster, safer languages to maximize the hardware they actually have.
Bun is a perfect example of this shift.
Oh, absolutely.
They built this incredibly popular JavaScript runtime, and they originally wrote it in Zig, which is a fantastic language, but it requires manual memory management.
And for anyone who hasn't suffered through manual memory management,
It's painful.
it really is.
Yeah.
It basically means the programmer has to explicitly tell the computer when to allocate memory for a variable, and crucially, when to free that memory up.
Right.
When you are dealing with the scale and complexity of a massive runtime, humans inevitably make mistakes. You forget to free the memory, you get a memory leak, and the system crashes.
So dealing with those obscure, hard-to-track bugs, what did the Bun team do? They ripped it out and rewrote the whole thing in Rust.
Because Rust gives them absolute memory safety guarantees without sacrificing native performance. It enforces strict rules at compile time, which massively improves stability.
It eliminates whole classes of bugs before the code even runs.
Exactly.
And it is not just Bun making this pivot. Microsoft just announced TypeScript 7.0, and they achieved a 10 times faster compilation speed.
10 times. That's huge.
Massive. And how did they pull that off? By doing a native port built entirely in Go. Then you have PJDog building a brand new Postgres database connection pooler. They built it using Rust's Tokyo runtime so they could handle session states natively and efficiently.
You see the undeniable pattern emerging across the industry here. Rust, Go, native performance, strict types, safety.
So I have to push back a bit on the AI narrative then. We have all this incredible tooling that can generate code at light speed. But for all the AI flash, if you want a system to actually work at scale, to handle real user load without falling over and burning expensive compute, you still have to sit down and hand code the foundations in Rust or Go.
It is worse than that, actually. You not only have to hand code it, but you have to deeply understand the underlying computer science.
Right.
We're seeing a forceful return to the mantra of, write code, not specs.
Good handwritten code establishes strict, undeniable patterns in your code base.
Which AI needs.
Exactly. When you build a robust, mathematically sound foundation in a language like Rust, you create a safe environment. Then, and only then, the AI can operate within those constraints without breaking the entire system. It provides the guardrails. You can use the AI to paint the walls and pick the furniture, but you are absolutely not letting it design the load-bearing walls.
No, absolutely not. And it proves a fundamental point that often gets lost in the hype. Learning to code is not just vocational training anymore.
Yeah, it's not just typing.
Right. It is not just about getting a job typing syntax into an editor. It is essential for understanding the underlying math, the logic and the mechanics of complex problem solving. If you do not fundamentally understand how a database connection pool actually handles memory allocation, no amount of AI prompting will save you when the system inevitably goes down at 2 a.m.
You cannot prompt your way out of a fundamentally broken architecture.
You really can't.
We are watching the industry transition from this chaotic Wild West phase of AI code bloat, where everyone was just generating as much text as possible, back to a deep, pragmatic appreciation for hyper-efficient, handcrafted engineering.
It is a necessary engineering correction.
Yeah.
The tools aren't going away, but they are finally settling into their proper place in the stack.
Which leaves us with a pretty stark reality for anyone working in this space. The developers who survive and thrive in the next wave are not going to be the ones bragging on social media about using an LLM to write 90,000 lines of code in a weekend. The engineers who actually survive will be the ones who know exactly when to turn the AI off, close the prompt window, and just write a clean, deterministic function by hand. If you want to untangle more of this with us, head over to vocaltechnologist.cu. That's .cyou. Vocal Technologists, see you soon.
Spoken Tech for your ears.